3D printing news Unpeeled, courtesy 3dprint.com. And today we're going to look at CAS. Now, this is something I was intensely skeptical about for a very long time. I was very, very skeptical about 3D printed CAS. And it's something that would not go away. I kept coming back, and it would be a design student somewhere graduating with this or a project. And I never believed in it. Really, I'll tell you this honestly. What I believed is in splints and very specific post-operative fixation and very specific braces and sports braces. Love that as a 3D printing application. But CAS specifically, I was always very, very skeptical about. Now, St. Luke's Hospital, which is a hospital system in Pennsylvania, now is going to use ActivArmor CAS. Well, they have been using them before, but the difference is they are now going to 3D print them in-house, inside the hospital, reducing the lead time from 4 days to 2 days. Now, still, I always thought that for most cases, that CAS would be cheaper to make and faster to make in the hospital using plaster. But St. Luke's Hospital loves these things for kids. They love the fact that they can clean them while the patient's wearing them. They love the fact that they can access kind of cuts or other kind of incisions and things while the patient's wearing them. They love the fact that kids think they're really comfortable. And they are so intent on using them that they want to be the first to use their hospital 3D printing lab to print them in-house. So this is really, really big news because of the implication. Because, um, how are these things made? These things are made. You use a phone to scan it. That can happen before surgery. Once a patient comes in, then that gets converted into the right file. It gets printed on a desktop 3D printer. Now, then the part gets hand finished with a Dremel and a 3D printing pen. So they use a 3D printing pen to smooth out some parts and make some parts nice. And then they use vapor fusion to make the part smooth. And then they send it off to the hospital. And now what the parts are just FDM, material extrusion parts, and they use, quite curiously, I think actually personally, ABS for this. And I would really think there's some other materials nowadays that might be a bit better. But hey, ActivArmor has been getting FDA approvals, all the right approvals for this, and now they're going to be printing them in a hospital. So this means that at one point, these hospital 3D printing labs that are now making surgical models, guides, and all this kind of stuff, one-off type of stuff, may start to serially produce things like casts and splints and stuff like that. And that is something I'm really, really bullish about. And that's something, these ActivArmor things, they are actually, in some cases, they can be covered by Medicare and Medicaid, right? So these systems really will maybe turn to this to pay for the production. And that could really make the hospital 3D print lab not only a hub of innovation, not only something to make teaching models and pathology models and things, or for models for like conjoined twins and stuff like that, but also could make it something that, well, could very well be useful for a really much larger group of patients. So to me, I'm still surprised at this. I'm still blown away. This has really positively surprised me. And it could really mean that the hospital 3D print lab, which now there's over 100, maybe perhaps 200, depending on how you see a hospital 3D print lab. There's still a lot of these in the world now. Could really kind of gear up into producing more parts in the hospital, which could lead to many more parts being produced. So that to me is big, big news. So the next bit of news is by John Deere. The Mannheim, Germany unit of John Deere has ordered 4,000 valve components from GKN. And GKN is going to be binder jetting these components in stainless steel using HP's binder jet technology, HP Metal Jet. So this is a big win for HP. It makes them sound a lot more credible, a lot more putting parts into a market, into a final vehicle. That's a really big win for GKN because it could mean that GKN could displace other traditional manufacturing companies through just doing the 3D printing. And it's a big win for BinderJet as well, showing the applicability of this technology and making like kind of everyday parts, relatively low cost. So this thing is a part. It's a relatively small part. It's a part of the fuel system of the tractor. It's called thermal diverting valve, which I don't know. Please comment if you know what that exactly means. I'm not entirely sure what this thing is exactly. It's just a pretty simple valve. The company says it's 50% cheaper than the other way of making it, and it has less mass, uses less material, and it makes it a little more agile because they can quicker implement this part for this particular production run. And the production run is 6R and 6M tractors. And it's a total of 4,000, and they ordered the parts. Oh, they also say, by the way, that the flow is better, which of course is nice because I really focus a lot of time on trying to figure out how this flowing energy, liquid, gas, whatever through a component could really be a business case for 3D printing. So that's good. But so this is good for Binerjet and HP generally, but I think I'm more interested in the GCAN component of this. GCAN is a 3D print service, also a supplier to car companies. What does this mean for them, right? Does that mean that GCAN now can repeat the same trick for Caterpillar and dozens of other companies? All right, are they just going to be more of a design and development partner to get these companies feet wet in 3D printing? Does it mean that GCAN is going to disrupt the traditional automotive supply chain, right? Does it mean it's just going to look at a tractor and think, okay, what on this tractor are we going to print, and then work together with Caterpillar to see how they can do a digital repair and digital manufacturing supply chain for this? Or is John Deere going to print itself, right? Or is the traditional manufacturer of the valves, are they going to switch to 3D printing? So what this does, this immense automotive and capital goods kind of supply chain is very interesting. Like, often the companies in tier 1, 2, 3 don't have the money to innovate and learn 3D printing and invest in this technology. Are they going to make the jump? Are certain companies going to make the leap into additive and other ones not? And what is that going to mean? For example, it could mean that, for example, for drive components, it could not have any impact, but maybe on valves, it'll have a lot of impact, not because it's going to print all the valves in the world, but just the really profitable ones, for example. So, to me, what's really happening here is there's going to be like kind of some conflicts, some opportunities, and some really, really big opportunities as well in the automotive and capital goods supply chain. And we don't yet know if it's the OEM, if it's tier 1, 2, 3, or specialized 3D printing companies, they're going to print these parts. So that to me, very, very exciting. Okay, next thing. This is actually, by the way, the component installed. I don't know if you have a better idea what this thing is. I really don't know. Okay. So, and by the way, it just seems like this is a way for them to monetize or slash like productize 3D printing. This is a way for them to, in a really enclosed type of project, make a kind of straightforward part that they can then get out the door and then learn how to 3D print and learn how to design for 3D printing internally. That seems the biggest logic for them, for me, is not the fact they optimize this valve. It's the fact that they're doing a public project at John Deere with BinderJet on printing, and they just decided, hey, you know what, guys, we'll put it on the tractor. Anyway, so the next thing, Addup, often overlooked, I think, unjustly so, because I think they do some really exciting stuff, is the French powder bed fusion metal company, and they have just released a new version of their FormUp 350. This is called the FormUp 350 Evolution, and it's 350 by 350 by a meter build volume. This means that alongside SLM Solutions, that's in excess of a meter, of course, thanks to the U.S. Air Force, in excess of Vela, which is up to a meter, and AMCM, which is AOS units up to a meter. They joined the kind of the 1 meter plus club in 3D printing build volumes. And that's, of course, driven by missiles, warheads, combustion chambers for rockets, space, defense, new space. It's kind of high value, very large for us then components. Nice thing is that it's compatible with the smaller 350. So if you qualify a part on the smaller machine, you can print it on the larger one. You can choose between the roller or scraper kind of solution, whatever you want. And yeah, this is a feature of Addup. What I really, really like is this extractable build volume. So the thing on the left there, you can take it out of the machine. You can lift it out of the machine. The gas will remain inert, and you can have a really nice, quick turnaround time just putting a new build volume in there, not having to wait for everything to heat up or cool down and all that. So I really like this. I really like Addup. I like this fact that this seems like a really productive machine. It's got a quad laser, full build, 500-watt lasers. And yeah, I hope it becomes a little bit more popular, a lot more attention to Addup. They deserve it. Anyway, thanks a lot, guys. This is a lot of news and some exciting good news, I think. Good news. Good news is always nice. And you all have a good day. My name is Joris Peels, and this is 3D Printing News Unpeeled.